I work in IT, and a lot of tasks are repetitive. So, let's PS it. Hey, what's going on, everyone? So, today what we are going to be doing is we are going to be talking about decimal, binary, and hexadecimal. So, this is a very important topic for people to understand. I recommend that pros, I recommend that intermediate, I recommend that beginners also come and watch this video. So, the foundation of software is binary. Everyone has heard that, hey, my computer runs on ones and zeros. But how does that translate to this wonderful video that you are seeing now? Well, to understand that, we're first going to have to talk about number systems, which is why I wanted to talk about decimal, our number system. This is the one that we are familiar with and we work with every single day. So let's start off. The first thing that we're going to define is we are going to define symbols in a numbering system. So for decimal, what we use every day, it means that we have 0 through 9. And when I say symbols, what you are looking for specifically is the maximum and also minimum values, as well as the values in between, that can fit in a single placeholder in order to just kind of talk about it. So, the first thing that we're going to do is we are going to just draw a quick little placeholder right there. Bam! So, what is the minimum value that I could have in here? Well, you might say, man, you could just put a 1 there, but because we're talking computers, everything always starts off with a 0. And so what is the maximum value that I could put in there? You're right, it's 9. Awesome. So, my question to you, and this is going to be a very specifically worded question, is if I want to go past the number 9 and get to the number 10, what do I need to do? And the answer is pretty simple, right? You just got to add another placeholder. Bam! Hey, congrats. We're doing math. So, let's talk about why this number is 9 and why if we want to make it a 10, we have to put a 0 there and a 1 here. Which is going to sound like kind of weird because, like, why is a 1 in this placeholder larger than a 9 in this placeholder? It doesn't really make much sense. So for that, we're going to have to talk about something that's kind of scary and, kind of freaky to people. And that is the base of the number system as well as exponents per placeholder. And it's going to make a little bit more sense when I draw this out. So, for the first placeholder that you have, you are always going to start off with what is going to go underneath the line here, which is going to be the base. And the base is just the number of symbols in that system. In this case, we are base 10. 0 through 9 is 10 numbers. And what you're going to do is you're going to start off at the 0th spot. This is the 0th power, and anything raised to the 0th is 1. So no matter what number system you are using, your first placeholder will always just be 1. So let's talk about the second placeholder and why is it that a 1 there is greater than a 9 in the first placeholder? Well, what we're going to do is we are going to draw a 10 there, except this time instead of being raised to the 0th power, it is going to be raised to the first power. So as you can see, 10 to the first is just 10. What you're going to do is you're going to do it times 1, and this is where we got this, and so that is what gives us 10. So in this case, we have a 0 here, but what we would do is we'd do 1 times 0, which is 0, is why we're just left with 10. But if this number had been, a 7 or something, it would have been different. So let's move on. This is stuff that we did in kindergarten, and it might just seem like kind of weird, having a 10 spot, a 100 spot, a 0 spot, or a 1 spot, I mean. And it's one of those things that is just going to take some getting used to. So, let's talk about binary now. What is binary? Binary is what runs your computer, We have two symbols inside of binary. We can either have a 0 or a 1. And the reason why that is because binary is actually just electrical pulses that is going through your PC or any device that you have. So if there is a current, it's a 1. If there's not a current, it's a 0. And that's why binary can only have an on or off position. So with our symbols identified now, let's talk about placeholders. We are going to use the same logic that we used up here for binary. So what I'm going to do is I'm going to draw out a couple of placeholders. Bam. And what we're going to do here is we're going to say, what is the maximum value that I can put in a single placeholder with the binary number system? Well, the minimum is 0. So the maximum must be 1 because that's all that we have. So then what if I want to go up from here? Can I just draw a 2? No, I can't because there's no such thing as 2 in binary. So that's when you would add the second placeholder. And you would put a 1 there. And now you have a larger number than you would with just one placeholder. So let's talk about the bases now. We talked about a rule about exponents and bases. So how we got the 2 here is binary is base 2 because there's only 2 symbols in the numbering system. This is our first placeholder, so we are going to raise it to the 0th power. So 2 to the 0th is just 1. We're going to have 1 times 1 is equal to 1. Awesome. So what about the second placeholder? Same logic. We're going to go with the base, raise to the placeholder. In this case, this is our first additional placeholder. So 1 times 2 is going to be 2. And yeah, so what we're going to do is we are going to do 2 plus 1. That is going to be 3. So that is how we would convert a number from binary into decimal, just so we can read it a lot better. The next thing that we are going to do is we are going to talk about bits and bytes. So a bit is equal to a 1 or a 0. And a byte is equal to 8 bits. So when I said that this was the fundamentals of software, I did mean it. Because, the word byte, I know it sounds like kind of weird, but you've heard it before. You've heard megabytes, you've heard gigabytes, you've heard terabytes, petabytes. You could keep going on. For instance, every storage component inside of your PC is associated with a byte, whether it be gigabytes, terabytes, and your RAM, it's going to be in the gigabytes. All these are just different ones and zeros that are measured differently. Just a different amount of bytes. So that is exactly why we are talking about this. So let's draw out 8 placeholders, and we are going to talk about them. So this is a byte right here that we have. So what we are going to do is we are going to start off by drawing out the exponents down here with the base for all these different placeholders. So we're going to go with 2 to the 0th, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, and also 2 to the seventh. So we're going to go ahead and multiply these out just so that you could see what each of these values is going to be. So right here, what we are going to do is since we have 2 to the 0th, anything raised to the 0th power is just 1. We already know. 2 to the first is going to be 2. 2 to the second, 4, 8, 16, 32, 64, 128. So I'm going to ask you a very interesting question now, because we are going to be shifting to the minimum and the maximum values of a byte. So what is the minimum value that I could have in all of these? It'd all be zeros, right? And of course, the maximum value would all be ones. Hey, look at that. So when everything is a 1, it is going to equal to 255. When everything is a 0, surprise, it's a 0. So the number 255 is going to pop up everywhere. You might have seen it if you're into web design or graphics design, and you've seen some of the HTML codes for RGB that you can edit, and you'll notice that it's a value between 0 and 255. That's exactly what it is, bits. That's how we get 255. It's the magic number that will pop up everywhere. So my question now is how many unique values are in here? If you're saying, oh, 255, easy, that's the maximum number, you're wrong. It's actually going to be 256 because you can never forget that 0 address. And we are going to go into why that is important in a future video when we talk about IPs and subnetting. So the next thing that we're going to do is I'm going to teach you how to get values and how I calculate binary. So with this table up here, we're going to draw 8 more placeholders. And now we're just going to go with a random number that I am going to choose. We are going to go with 188. So the easiest way to figure out where ones and zeros go in your placeholders is you're just going to do subtraction. So is 188 larger than or equal to 128? Yeah, so you're going to put a 1 there. So you're going to do 188 minus 128. So now you're left with 60. So is 60 larger than or equal to 64? No. Is 60 larger than or equal to 32? Yes, it is. And you're going to be left with 28 remaining. So is 28 larger than or equal to 16? Yep. And then we are left with 12 now. So is 12 larger or equal to 8? Yes. Is 4 larger or equal to 4? Yes. And then obviously we don't have anything left because we've just got to 0. So the rest of these are going to be 0. And we just calculated out this number 188 in binary using the chart that we made earlier. Same for the powers that we generated. Just the values. These aren't going to change at all as long as you have 8 placeholders for your byte. So the next thing that we are going to talk about is hexadecimal. And hexadecimal is kind of unique because I like to say it's kind of like the easy, well, I shouldn't say easy, I should say more readable version of binary. So let's talk about hexadecimal now. Hexadecimal. Awesome. So, what is it? Hexadecimal is another numbering system that you're going to see a lot in computers, in IT in general. So, the first thing that we have to do is we have to figure out what symbols there are here. So hexadecimal, kind of weird. It seems like there's 16 symbols. It's hexadecimal, awesome. So we don't have anything larger than 9 in our numbering system now. So we are still missing 5 different values. So what are we going to do? Well, you're actually just going to extend it to F. So it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. These are all the symbols that can be in hexadecimal. As you can see, we added 6 additional letters up here. And that is how we got the hexadecimal. So let's talk about generating numbers and why is this easier? Why is it more difficult? Let's just get straight into the math. So up here, we've seen binary, seen placeholders. We're gonna follow the same logic of exponents. We're gonna go back to drawing, blam, blam. Gonna give us two placeholders. So what do you think that the base of hexadecimal is if we have 16 different symbols in there? Good job, it's 16. So anything in the first placeholder is just going to be 0, so this is going to be 1. And we're also going to generate the second placeholder, which is going to be 16. So let's talk about the minimum value here. If we put a 0 in here and we put a 0 in here, what's it going to be? Just 0. Awesome. So what if we put an F? Because we agreed that F is going to be equal to 15, so that way in our base 16, everything will line up. So what we're going to do is we are going to do 15 times 1, which is just 15. So what we are going to do then is we are going to do 15 times 16, which is 240. And we are going to add these two numbers together. And oh my gosh, would you look at that? It's that magic number, 255 again. Yay! So, what is cool about this and what did I mean when I said that it was more readable? So let's talk about it. So hexadecimal, if each one of these has 16 different combinations, and we go up here to binary, if you look at it, you can split a byte directly in half. So each side will have 4 bits, and 4 bits will give you 16 total combinations. So what we did is with hexadecimal, we just divided a byte in half, so instead of having 8 things to look at, now we only have 2 things to look at, and that is why it is more readable. So let's do another number, just so that we could clarify. So we're going to do 16 to the 0th, which is 1, 16 to the 1st, which is 16, and let's come up with another number. Let's come up with 188. Alright, so the way that I like to do this is I know that I'm going to be multiplying this by 16. So what we are going to do is we're going to see what is the most times that 16 will go into 188. So can it go in 10 times, which would be A? That'd be 160, and we could still fit more. So what about 11 times using B? So instead of 160, now we're at 176, and we can't go higher than that. So we know that our first value is going to be B. And you always want to start off with the largest to subtract. This way, your math doesn't get too complicated. And we're left with a remainder of 12. So when we come over here, how are we going to get 12? It's not going to be A, it's not going to be B, it's going to be C. Why? Just because. That's how hexadecimal works. So, if you have questions or you'd like to try out any of the hexadecimal or binary problems, let me know. You can go through, you can practice them, and if you have any questions, go ahead and leave them down in the comments. If you have any suggestions on the video, let me know. I am brand new to this, and I am open to your opinions so that I can produce better content for y'all. Alright, take care. And don't forget, if a task is repetitive, let's PS it.